Good evening, ladies and gentlemen. Welcome to Vegas. No, I'm just kidding.
Hey, welcome.
My name is Clayton Banks. I'm the CEO of Silicon Harlem, and we are honored to have you all here, especially since we just opened. A couple years ago,
Enjoy.
Thanks. Good to see you too.
Thank you.
All right, take care.
They sometimes have the art gallery there.
This is Harlem. That's what you get. You know, we started our company in 2014, we incorporated in 2014, and in that year, essentially, actually go back. 2013, I'll just be very quick here, but 2013, we started a meetup. And the reason was there was no meetups in Upper Manhattan. And we were always going downtown or Brooklyn, wherever, to go to meetups. And Bruce is the co-founder of the company, we said, why don't we do a meetup uptown? It'd be really cool if we could get, 20 or 30 people to come out. And we had a friend that had just built a nice space on 116th Street. It was still under construction when we did the meetup. And we said, why don't we, maybe even feature a startup or something like that, It was 2013. Plenty of meetups going on around New York City, but there's none going up in Manhattan. That night, 500 people came out. And that's when we knew we were not the only geeks uptown. And we started doing meetups every month. And when we were interviewed, because the press started hearing about us, mayor started hearing about us and everything else, what's these crowds coming uptown for? And we had said, well, we were hoping to create a bunch of these sort of co-working spaces and meetups, and we're hoping to really drive a startup community in Harlem, and we're hoping that, frankly, companies will come here and young people will look at a career here and stuff like that. And I can report to you 4 years later after that interview, every single one of those things have happened. There's an actual tech ecosystem in Upper Manhattan. And if you don't live here, you should, because it is the best place, literally, in New York. Most accessible. There's 5 bridges that come into Harlem. No other borough that has it. I'm just giving you the facts. It's a great place to live, great place to raise a family, all that kind of good stuff. But most importantly, like I said, our company really was focused on building an ecosystem in Upper Manhattan, and it's working. Companies have located here. People are now, even in our public schools, we've been emphasizing STEM. So we have more STEM programming going on than ever. When we started, there was virtually none. 2013, none. So we're and so one of the big achievements was I met Adam Newman, CEO and founder of WeWork. And we became BFFs in some weird way. And we convinced them to put a WeWork in Harlem. And if you've never been there, you should go. It's on 126th and 5th Avenue. We were the first ones in there. Of course, we helped bring it into Harlem. We sold it out 2 weeks before it opened. We stayed there until we moved into our own space. We're a success story at WeWork, because I always tell people, you don't go to WeWork to stay there forever. You go there to start up and then get your own space and your own building. And we now have our own space. So you guys are some of the first people to be in the brand new Silicon Harlem headquarters. And we're proud of that. Thank you very much. So my role here tonight was just sort of to welcome you, let you know that we're very excited to be partnering with Space Apps. I always acknowledge Jolie over here. You probably have seen him at a variety of events. He's Mr. Internet Society, so he's been, and look at that. You can see how long he's been around. Very loyal, and has been very good to Silicon Harlem. We're always excited about him. And lastly, I'll say, well, I shouldn't say lastly, but I just want my team to sort of be acknowledged. You've got Raku in the back here. Raku, wave out for everybody, stand up, whatever. That's my assistant. Bruce Lincoln, I mentioned earlier. You see Lloyd standing over there, who's been tinkering around with everything. He's one of our partners. Eric Cunningham over here, who's our CFO. So they all wanted to hang around and see what was going on because we normally don't have anybody in here, so it's nice. And like I said, we are so proud to be. I've been at the Space Apps Hackathons. We've brought kids to that because we also teach kids. We constantly are trying to increase the digital literacy in Upper Manhattan. So we're in front of kids all year long and all the time. And now it's beyond Harlem. We go into Brooklyn and Queens and everywhere. And we've brought our kids into the Space App Hackathons, and we've always enjoyed it, always have enjoyed it. So it was a no-brainer for us to want to host this here at our space. And I have to really acknowledge Google for what they're doing to be partnered with Space Apps, and they do so much in the community. We're having a conference on October 26th. The flyers are all around here. I think it's a must-go event. It's called Rethink Everything. You hear what I'm saying? Not everything, everything. Everything that's currently inanimate will become animate, right? So the streets and the walls and everything else will be smart, learning from us, hopefully helping our lives. You want to come to this conference to hear about the future. We're going to be focused dead on next generation technology. And it's important, just like you're going to be dealing with this here, with Tez going through everything here, all that's going to translate into our entire infrastructure. So with that, I'm going to turn it over to the man that we connected, I guess, early September, and Joseph was like, hey, man, we ought to do this thing. You know, do you got any places up in Harlem? And we were just sort of transitioning here, and I was like, why don't you come to our space? And he was so desperate, he said, okay. So I was cool with that. And so it's my great pleasure to bring up the star. You guys all know him, because most of you probably have heard from him, the great Joseph Spence. Come on up, Joe.
Thank you, and thank you, Clayton and Silicon Harlem, for hosting us here in this beautiful space. As Clayton's mentioned, we've been looking to come uptown and partner with Silicon Harlem for a while now, and it's great that you have your own space here, that we don't have to go chasing down other organizations to try to book time and whatnot. We can host it here right in Harlem with Silicon Harlem. Thank you. Cool, so my name is Joe. For those of you who don't know, my name is Joe Spence. I'm the Executive Director of Space Apps NYC. Hopefully most of you gotten our emails by now promoting it, but if not, come find me afterwards or go on spaceapps.nyc, sign up to our mailing list. We have a lot of really cool events coming up. We are a nonprofit grassroots organization of space hackers in New York, and we've come together to host the Space Apps Challenge. The Space Apps Challenge is an international hackathon run by NASA. It's been going on since 2012, as Jolie's shirt has told us earlier, in which tens of thousands of people worldwide, tens of thousands of people worldwide have collaborated in one 48-hour weekend to build teams, work on projects that solve challenges in space exploration and Earth science. Last year we had about 25,000 participants worldwide, building about 1,300 projects across 69 countries and 187 cities. This is all happening at once. There's a lot of virtual participants. You get to interact with people from other cities, other countries. Virtually every language is present in the Space Apps Challenge. And it really makes for very interesting solutions because these global challenges really resonate at a local level. You think of in New York, food waste, housing, transportation, a lot of these things are problems that would be fun to solve on Mars, and you could bring the solutions back down to Earth and apply them to everyday life. So I just wanted to skip that. What we're looking to do is not only build a community around the Space Apps Challenge, we're looking to host events like these throughout the year. These events, this is actually the inaugural Data Bootcamp. for 2018. It's a series of evening workshops which are meant to prepare our hackers for the hackathon. Since you only got 48 hours to work on something, we really want to prepare you as much as possible so that on Saturday morning you can hit the ground running and have something presentable by the end of the weekend. So we have boot camps like Intro to Google Cloud. We have an Intro to Open Space that's going to be at the Lower East Side Girls Club next week. We have an Intro to the Space Apps Challenge and Open NASA APIs. That would be next Monday. That's just an introduction to the hackathon if you haven't been to one before. It's also an introduction to various open NASA APIs that you could use for the hackathon. We partner with organizations throughout the city, space organizations, tech organizations to host these meetups. These are the ones that will be leading up to the hackathon, but we're also going to have ones after the hackathon. So that's why it's very important for you guys to go to Space Apps NYC and join our mailing list. These are just some of the events that we've been working on. We also do some social events like a season finale viewing party for The Expanse. It's a sci-fi TV show going into its 4th season on Amazon. We just had a kickoff cocktail party co-organized with Women's Sphere to kick off the Space App season. It was very fun, and we're going to be posting videos of it. You guys should go check it out. And we also, a few years ago, co-hosted a Hack the Universe hackathon at the Museum of Natural History, which was very fun. We're looking to do more hackathons throughout the year at various locations around the city in which people can use NASA and space APIs to build really cool projects in really cool locations. So that's my plug. Feel free to come and chat with me if you would like to volunteer to run any of these events. We're looking for volunteers for everything: social media, sales, getting some sponsorships. Thank you, Tej. Really anything to grow our organization and make us more productive. We'd like to thank our sponsors through Google Cloud up there. We've developed a lot of really great partnerships over the past few years, and we'd love to explore more opportunities to run events with them. And just like we're hosting here at Silicon Harlem, we're always looking for new venues. So if any of you know of any, we would appreciate a shout out, and we would connect with any organizations you guys are familiar with. So that's it in a nutshell. Our hackathon is next weekend. I believe I have that right. It's October 20th and 21st. It's a Saturday, Sunday. And we have a pre-event on the 19th, which is an orientation event to get you familiar with the space and the challenges. We'll form teams so that on Saturday you can hit the ground running with your solution and hack throughout the weekend. After all, we'll be live streaming the whole thing with Jolie, and we'll be posting videos afterwards. So if you can't make it, don't worry. Follow us on Twitter and Facebook, and you can stay up to date with everything. So thank you. With that, I'm going to hand it over to our intergalactic sponsor for this year's hackathon, Google Cloud. Tejpaul is the startup. Go Tej. Tejpaul will be here talking about giving us an intro to the Google Cloud platform and also talking about artificial intelligence and machine learning at Google. So, Tej?
Hi, everyone. Thank you for having me. It's great to be up here. Quickly, I'll give you my my quick background, and we'll jump right into it. I am the startup program lead in New York for Google Cloud, which means my job is to get deeply involved in the New York City startup ecosystem, connecting with early stage startups, that is companies everywhere from formation to about $5 million raised if it's a venture-backed company, or $500,000 to $1 million a year in revenue, anything below that. So we're trying to get into the earliest stages of the startup. And the way we do that is we partner with groups like Space Apps, Silicon Harlem, universities, communities, accelerators, venture funds, and we provide access to Google unlike it's ever really done before for early stage startups. Core to our program is a credits program, which I'll talk about in a minute. I'm going to take this down, but I'll put it back up. For everyone who is going to participate in the Space Apps Hackathon globally, everyone gets $300 in credits to tinker around with Google Cloud and a bunch of different services that come with it, which we'll talk about today. For startups, you can get $3,000 in credits. I put eligible startups there for a reason. Eligible means two things. Either you're in a startup today, or if a startup comes out of the hackathon, that counts as well. So this link will be available for 2 months after the hackathon. So if any idea comes out of the hackathon and you actually want to follow up with it, you can. So my quick story is I joined Google about 5 months ago. I've been in New York my whole life, Manhattan mostly, and I started 3 companies here in New York over 10 years, all investor-backed. Most of the investors are New York locals, and I had various levels of success and failure, probably more failure than success, but learned a lot and was really excited when Google called me to play this role because I didn't know this type of role existed. And it lets me interact with a bunch of very cool people doing neat things. So I'm going to start with the slides we had prepared for today, but I want to make this a little more interactive and tailored for the group. So the goal here is threefold. First, I'd like to give an overview of cloud computing, then machine learning and artificial intelligence. But the whole point is to give you actual practical tools that you can use at the hackathon. So with the credits you get, plus the tools we're going to go over, you should be able to quickly put out a really powerful application or system using the tools that you get with these credits. So I'm going to start first with an overview of the Google Cloud Platform, and then we'll stop for questions in between. But just so I can get an understanding from the room, how many people here think they know what cloud computing is? Okay, on a spectrum, how many people think they really know a lot about it and they should be giving the talk right now? Okay, you can't ask questions after, but no. And then on the other side, and don't be embarrassed, how many people have no idea what cloud computing is? Anybody else? Which is fine. It's actually, the point is for it to be invisible. So I will give a high-level overview. I'll give you an overview of what it means for Google. And then, like I said, we'll open it up for Q&A, and then we'll get into more practical uses towards the end. So Google 20 years ago, almost exactly 20 years ago, set out with this mission information and make it universally accessible and useful. And they've stayed true to this mission throughout. And one of the most amazing things for me is there's 7 products, all built on Google Cloud, that have over 1 billion users each. So they really build things at planet scale. And when most of us think of Google, we picture this: a simple search engine, a design that hasn't changed in 20 years, which is amazing, and that's what we all know and love about it, and it works. Most people at Google, though, when they see this, they see something more like this. This is 20 years of infrastructure and hardware and dedicated fiber under the ocean that Google has spent billions of dollars, billions of dollars every year, building and refining to make sure that when they organize the world's information, everybody in the world can actually have access to it. And what Google has done with Google Cloud now is taken all this investment and innovation and make it available for all of us so we don't have to do any of this stuff. So there's a couple of key things, and then I'll stop selling us on Google, but one is the network. So cloud computing and just the internet in general is built on this concept of servers, machines sitting in all these locations. And Google, unlike other cloud providers and internet companies, actually built its own network. So most of the rest of the internet that we use goes on the public internet. Google doesn't. It actually has its own fiber between North America, South America, Africa, and it's building more every day. Now, most startups, it might not matter. The internet's fast enough, but if you're doing things, in the milliseconds, microseconds, nanoseconds, and you're moving information from, California to Singapore, and that little delay matters, it actually makes a huge difference. Second, something paramount for Google and super important is security. And security is at every level. So from your username and password, I know someone was asking me about that, how hard it is to reset it and all the multi-factor authentication it takes, but also all the way down to the hardware. All the servers sitting at Google's facilities actually have custom-made hardware chips on them for security purposes. So again, this is all stuff that comes with, these are all things you don't have to worry about because someone else did. So cloud at Google means a lot of things. Many products you guys all use, Gmail, Chrome, Android, Drive. What we're going to focus on today is really this bottom tier. Not so much the business platforms or the productivity tools, but really the underlying mechanisms for how to build an app, how to build a backend, a database, and how to make them all connect. And again, the purpose of all this is to enable app developers and software developers to just write code, not spend time actually, getting servers in racks or running operations or doing anything that any of us had to do 20 years ago, 10 years ago, even 5 years ago. So you should be able to, let's just use this hackathon as an example, prototype something that weekend, put it out in the world right away, see if it works, people like it, and let's say it's validated, you should be able to get into production right away and at planet scale. If it goes to 1 billion users overnight, so be it, even if it's not the best written code. So at the top of this is our compute engine. This is if you are going to be actually provisioning machines, you need a server, you have a certain operating system. I suspect that most people here won't, and I kind of recommend don't doing it, but if your needs are at this level, this is something that Google definitely provides. And these are virtualized machines. So a server is a computer, and back in the day, you would actually plug the computer in or anywhere, and if it was a website, a browser would hit it, and the two computers would talk. What a virtualized machine is a representation of that. You don't actually have to have the physical machine. There's tons of them sitting at our center. You can bring it up with the exact specs, the amount of RAM, the amount of hardware, and whatever information you need. And if it were to go down, you don't have to buy another machine. Another one will virtually pop up. It makes life a lot easier. And there's a whole bunch of other things that come. It's way cheaper, and we can talk about that if you have questions. The second thing I want to talk about is Kubernetes. Who here is familiar with Kubernetes? Okay, this concept of containers, again, we're talking about these virtual machines. You can actually now, literally a concept of a container, create this virtual machine with all the specs you need and run it on your local machine and have all your developers work on it and deploy it with a single click and know you're going to get that consistency across all the different tools we use. We highly recommend it. You may or may not need this for the hackathon, but we'll talk about it. But if your startups are getting to the point where you're doing modern software development, this is what we're seeing a lot of startups using. And then finally, our app engine, what we call platform as a service. Again, this allows you to focus just on code. You can write in any language that you prefer. You can build and deploy using Kubernetes and do it at a click, and again, seamlessly scale up or down. And kind of one of the most important parts for me is that you're only paying for what you use. So even in this level, and we'll talk about this, you can build apps where if nobody uses it, you don't pay anything. Or if one person uses it for one function, you only pay for that second of usage, which I think is great for the hackathon. Hopefully lots of people will be using it, but. And then if you have detailed data needs, we have multiple databases. Again, I don't want to go too much detail into technology, but we can definitely talk about it after. But kind of everything you might want, whether it's a specific SQL database or you want to use some of our proprietary stuff that we built at Google, it's all available for you on Google Cloud. Again, there's a little more detail about the different types of databases, whether you need instant access type of data or stuff that you need to archive. Even for the long term, you have all those options as part of Google Cloud. And that's the cloud platform in a nutshell. I know we didn't go into a lot of details from a technical standpoint, but I wanted to just open it up for questions before I move into the heavier stuff.
Any questions?
Yeah?
So if you're doing some like machine learning training and stuff, and you're going to be running on like are you still able to do that containers or with a
Yeah, you can. It's about how you configure it. We're going to talk about it a little bit. You'll see. You can get as much, you can customize as much as you need. And with the credits, we call them TPUs. You actually get access to all that stuff. You may or may not need it, especially for the hackathon, but.
So I really didn't have much understanding, so I just wanted to just like kind of recap, like to see if I understood. So basically, the cloud is where data is stored. So Google has its own data centers, which then stores information for like other businesses.
Sure. Yeah. So that's one way. We do call them data centers, and data storage is a part of it. So cloud computing is everything from the storage to the actual applications. So again, this concept of a virtualized computer in the data center, there is physical computers, but you as a developer don't have to worry about that. You will still develop code and deploy it like you would a server, but again, it's all virtualized. There's a whole team of people that are managing the actual devices. So when you hear people saying cloud, I mean, you can think of it as the internet or just these data centers. My understanding of where the word cloud came from is old architecture diagrams. The network or the internet was always a cloud, so that's why they call it cloud. But it's really just, again, this virtualized concept of a physical computer.
Thank you.
Which includes storage and.
How does location affect like your application? Are you just like limited to like, let's say I build an application in the US, but I do want users in Europe to make use of it. How does Google Cloud?
Yeah, so you're not limited at all.
No.
It's all replicated. And now if this was 20 years ago and you built a data center here, you would definitely have that problem where you would need to mirror a data center in Europe. But this all happens under the covers now.
Okay.
Yeah.
Sorry, based on, given that you've got new regulation on Europe and called GDPR,
Yeah.
how is that handled in terms of access, etc.?
Yeah, so.
Because there's no safe harbor laws of
Yeah. So
sorry.
I can't speak to that too much from the policy standpoint just because I don't know. I can definitely speak to it though from the startup side. Companies have had to deal with it. So large companies like Google had to do quite a bit of work. But what we're talking about here in terms of the physical location, yeah.
Hello? Yeah.
Yeah.
I assume that when you're talking about these virtual PCs, so basically you'd have a PC and basically on Google servers, and they would just send you the images of what's happening on the machine, right? So basically all they have to do is minimize, send you just the view, and that's it. That's how it's so fast, right?
Yeah, so it depends on what that view means to you. Like, you could literally run a Windows machine in the cloud and view it as if you're using Windows. Mm-hmm. But you could also run all these back-end services through a command line. So there really doesn't even have to be that. Yeah.
Okay. So it's pretty fast, but I guess it's not really fast as if you have your own PC. This is all amazing stuff, but I mean, compared to having your own super fast PC.
But remember, these servers are the ones that billions of people are hitting, right? So it's not so much about like, it's not about you using it for one application. It's for billions of people using your application.
Definitely incredible. Okay, well, thank you.
Great presentation, Tej. I had a question. So cloud computing is pretty much becoming more and more ubiquitous, right? Like everyone's basically going into the cloud.
Yeah.
How do you have, I mean, maybe I missed some of it, but you were explaining how the advantages of Google's cloud, whereas AWS seems to have a pretty big share of the market. How do you compare to that?
Sure. So
why would I move from AWS?
Yeah. So a couple of things. One is just kind of that shift that a lot of us.
AWS is Amazon Web Services who aren't following this stuff.
Yeah, and there's a few others. There's Microsoft, IBM, DigitalOcean, a few other players coming into the market. So one amazing thing for startups is that this exists, right? There's been a major shift that allows us to create amazing applications, which we'll talk about, which wouldn't have been possible with without the power of cloud computing. You basically have unlimited power at almost no cost. Now, so it allows startups to do amazing things. Google's cloud differentiates in a few ways. And for full disclosure, like I said, I did 10 years of startups, 3 startups, all cloud native. I used Amazon for 2 and Microsoft for the 3rd. I never used Google. And coming in for interviewing at the job, I told them that clearly that, you know, the market share is such that you have to offer value above the commoditized piece, which is, hey, we don't have to buy servers, which is great. Everyone does that now. Google's has a few advantages that I think are fundamentally different. One is this network, this private network. Like I said, for most startups, it won't matter, but when you get to a level of scale where sending that data from here to Europe matters, you'll start noticing it. And a lot of fintech companies, big data companies, blockchain companies notice this early in their life cycle. Second, artificial intelligence and machine learning, which we'll talk about in a few minutes. Google is the best at it. And we'll talk about a couple of products. Google is very open about it. They open source a lot of their tools, so we get the power of the community building on it as well. So when, and hopefully your startup gets to that point, you can leverage everything that Google uses for its own products. And then third, for me, this is not so much a technical piece of the cloud. Like if all things were equal between any of these, this is Google, right? So even if you're not using Google Cloud for cloud computing, you're more than likely using Gmail. You know, you're using G Suite. You might need to interact with Maps. And I think you asked me this earlier, that is all Google Cloud. So these credits that you get are specifically for cloud computing, but there's several other benefits of being part of our startup program, which is G Suite accounts, credits for the Maps API, and a bunch of machine learning things that we'll talk about in the next module that are just kind of out of the box.
Another question over here?
I know you're talking about G Suite in terms of companies that have G Suites, but for some of us who are consumers, and since Google Drive has now been separated out into different apps, can one kind of consumer go in and just play around and download some major data, bring it down in and do kind of queries in terms of Power Query?
Yeah, you can play around with Google Cloud on that. Is that what you're asking?
Yeah,
like,
exactly. I mean,
I'll bring this up again. There's 2 tiers of credits. There's the startup credit and the free trial.
Yeah, it kind of borderlines the AI versus
You can play with the
learning
AI
type of-
stuff.
yeah,
Yeah,
exactly.
you can. And I'll show you how you can do all
Okay,
that.
super.
Yeah.
Thank you.
I got a question. So you talked a lot about all the really cool things about cloud computing, how you could, with a few clicks, configure an application on the cloud, deploy it real quick, scale up, have data centers everywhere, everyone can use it. I'm a software engineer. I've been developing web applications for 8 or so years. The cloud has been there for most of the time. I'm used to cloud computing. But I know a lot of people who were coding before cloud computing. Can you just highlight some of the pain points that existed before cloud computing, like the size of the DevOps teams and all the things that went into
so
that?
I can give you a couple of personal stories. I can give you a couple of analogies. So the way you're talking about cloud and pre-cloud, and you've been doing software engineering for 8 years. When I was studying it 22 years ago, people were talking about that. Like similar stuff, but about machine language. They would tell stories like, I used to write code in 1s and 0s and have punch cards. To me, that was just like, that's not. And there wasn't like debugging software, and it's like, so it's going through one of those evolutions where to the point where it won't matter if you know what cloud computing is or not. It's going to be invisible, and that's just technology evolving. But some examples. So 20 years ago, if you raised $1 million for a startup, that money was gone on leasing of hardware. Like you could not build a startup with like 20K from an accelerator. It would do nothing for you. Second, if you fast forward even 10 years, so like 10 years ago when I was doing my first startup, was all cloud native, it was pretty raw. Like it was virtualized servers, but you were going in through a terminal, and you were back in like Linux days. You might as well have been working on your own machine, which was really cool. But the second you hit scale, that server would crash. and then you'd have to deploy others, your cost would go up, you'd have to actually architect load balancing, and you would have an entire team called a DevOps team, development operations, and they would manage how your developers deployed code, how you kept your production environment, staging environment, development environment separate, and DevOps people are amazing, and CTOs create all these processes, but you still hear nightmares of companies today where someone pushes a wrong button and production goes down for 40 minutes. That shouldn't happen. And a lot of what Google Cloud is offering, and it doesn't mean, DevOps was one of the hottest job titles before maybe data scientist. You know, like Google and the other clouds are making now this concept of no ops. Like your engineers should focus on writing code. They shouldn't worry. Like, for example, Kubernetes is this containers engine. There are DevOps teams that manage deployment of Kubernetes, like the clusters that they run on, which is kind of silly. The whole point of this is to make life easier. So a lot of stuff that we're doing on Google Cloud is so people like you can tell stories to the next generation. Like back in my day, I used to do this.
Great. Any more questions?
Just one question.
Coming up.
Could you describe a little bit more about the containers, if you could? Like,
Sure.
Or if you got, like, if you have this in front of the session, you can.
Yeah, I don't have anything in here, but we can definitely talk about it. But again, the concept being that not allowing for errors and being able to guarantee the environment that you're.
It's like the same stuff that you said about the DevOps.
Yeah.
It's more protective
and more protected, more automated, less likely to make.
Don't have to depend on the team.
Yeah.
Which they
And for example, your engineers working who are not necessarily ops people can actually be testing exactly in the environment that will go out to production.
Oh, thank you.
You know, it's workflow automation, but using, you know, these buckets that are mapped to the actual environment.
You've talked a lot about the upsides, and you have not talked anything about the downside of using Google Cloud. But one question that I have is that I know for especially users that are used to using, let's say, like a pre-cloud computing, one of the concerns they have is losing control over their data. Can you talk about that?
Yeah, so we will definitely talk about that in the next next module, which is about machine learning, where it actually becomes a very interesting dilemma, right? You can do everything on your own and keep your data isolated and use all the tools, but then you're not getting the advantage of the giant data set that Google has as well. And it's a very valid trade-off. Like if you're a startup building some amazing technology, you might think, okay, I want to use your tools, but why would I make you smarter? On the flip, you can say, I hope you get a lot smarter so I don't have to work on this. And we'll talk about in the machine learning piece. Now, in terms of data and purposes, again, even though it's cloud and virtualized, there's flexibility down to almost the core levels of the computer, which obviously is not the physical hardware. You can't touch it. But you can actually build your entire system completely isolated and protected. And there's kind of levels of it goes kind of from flexibility to not. The more you want your stuff isolated, the less flexible the system is. You might need ops people. You might need to deploy your own load balancing and cross-regional stuff. And you have the access to do all that. Yeah.
Cool. So I think that wraps up this Q&A.
Yeah. I'm just going to power through the three modules, but if you guys want to take a break, we can. They all kind of build off each other, so.
What do you guys think? You want to move on to the next one or take a break? Let's keep
Okay.
going.
Yeah. And they're all like this, all like 10, 15 minutes, then we have time for questions. And again, these first two are kind of high-level theoretical, just so you have the right vocabulary. And then what I'd like to get to is to show you like how you could actually build something. So this next slide is about machine learning and artificial intelligence. For the sake of this, let's call it machine learning. Same question as before. Who here thinks they know what machine learning is? Okay. Who thinks that they should be the ones talking about it right now after you saw my performance on cloud? Okay, nobody, good. So we can, oh, you wanna? All right, now flip, who doesn't know what machine learning is? Okay, good. So, just a question, if you remember, which you probably don't, but how did you learn your first language? If that's your first language, or?
I got two, so it's like, that I have done.
These little picture books, like notepad.
No.
From your parents.
Parents. What did you say?
Through osmosis, just like all the people
Yeah.
around you speak.
Yeah. It's not likely that your parents handed you a dictionary and said, these are the rules, and you learned. It was by talking to your parents, seeing books, friends. An example is the first time you saw a dog walking by. You might have been scared, happy, confused, whatever it is, and your brain might have interpreted 4 legs, cute, scary, whatever, and your parents said, oh, that's a dog. Happened a few times, and you start recognizing it's a dog. Then a cat walks by. And you might think it's a dog, but your parents say, no, it's a cat, and you learn. So what machine learning is basically emulating how we learn through a machine. So that's having a machine solve a problem without giving it the pre-described solution. So it creates systems that can actually get smarter over time through pattern recognition, through multiple data sets and iterative tweaking of data. And just so we're on the same page, there could be a lot of debate on what this means, but for the purposes of this presentation, artificial intelligence is the science of making things smarter. You could argue that cruise control in a car was artificial intelligence, and I believe it was probably before my time, but people were scared of that. And now compare that to what automated cars look like now. And it could be obviously smarter stuff than that. Machine learning is building machines that can learn. And then we're not going to talk about this, but you'll hear some people say neural networks. This is a type of algorithm that's used in machine learning that kind of mimics how the brain works, but it's a way of a computer learning about something. So the key to a successful machine learning project, and you guys will have all this at the hackathon. So again, my goal of this whole presentation is to give you something that you can actually use on the 19th. One is a large data set. This is not 100% true. You can actually get some really good results with small data sets if you leverage a system like Google's that actually is built on a large data set. But for the most part, for a machine learning project to be successful, you need a large data set. You need access to a ton of compute power, which again, the cloud has done for us, which wasn't possible before. And you need powerful tools and frameworks. We talked about some of them. We'll talk about them more here, as opposed to having to write programming on how to train your machine to get smarter. And again, this is why you're seeing so much of this now. Before it was kind of theoretical. Google itself used to call it artificial intelligence, then became machine intelligence, and a lot of that went with the wave of what society thinks about it. We're hitting that point where it's very real, and I'll show you some examples where it's being applied in all of our lives every day, and it's made possible by cloud computing, which again, you all have access to for free for this hackathon. So a couple of reasons why it's all coming to a head. Not only is it cloud computing, but just to give you an idea of the rate of change. The last 500 years of human knowledge in society adds up to 12 exabytes of data. All our books, all our knowledge, religion, photos, anything you could think of, that's it. In the last 48 hours, 12 exabytes of data were created. So basically, every 2 days, we're taking all of human history and adding to it. And that's growing exponentially. And it's just getting more and more and more and more and more. So this explosion allows us to do really cool stuff with the data. So we talked about this. There's 2 ways to build machine learning. One is train your own data. Google has open sourced its tools. TensorFlow is a name you're going to hear a lot. We have another one called the Google Machine Learning Engine. And this tends to be used by data scientists and people who are really experts in this field. They can use these powerful tools. They can provide their own data sets. They can use our computing platform, or they can put it somewhere else if they want. And they can use our tools to write the models to train their machines on their data set. The flip is to use our models. You don't need any tools. You don't need any expertise. I'll show you how to do that. And like I said, it could be large or small data sets, but you can get all the power that large tech companies have inside your apps. And just to be a little more clear about what we're talking about, in the build your own, it's TensorFlow and the machine learning engine. Again, all the same tools we use. This one's open source. It's actually the most popular open source AI project on GitHub. So Google, created it, but what's being created by people at hackathons and communities and stuff is amazing. Or you can use our tools. So Vision API, you give it a photo and it'll tell you that's a face. It'll tell you it's a smiling face. It can tell you who it is, just like your contacts and when you're tagging photos. Speech API, speech to text.
Is that what Lens uses, the Vision API?
Yeah. And that's also, now that's a lot of stuff. There's also a video intelligence API, but this one used to be the Photos API and the Vision API. It's all now in one.
Vision API is part of machine learning engine or TensorFlow? Or both?
So it's built on this. So, friendly machine learning. So like you can take the underlying tools and build your own machine learning process, or you can use the ones we've already created.
So you need to use the credits to use the ML APIs?
Yeah, you can. Yeah.
Or is there like a free set of queries you can send to?
No, the credits are as if you put your card in.
Okay.
Yeah. And you'll see, you can also use those serverless options in the next module. I'll show you how to do that. So. There may be some, you can play around with it. There are some things, but to actually build something on it, the credits will get you the access to it though. It's all part of the cloud platform.
Question, is there a user interface or do you have a user interface in front of any of the tools, or do you have to get to it through the API?
We'll talk about that in the next module. Short answer is yes. So we have an interface. You can use your own as well. You can use command line. You can use our console. You can use GitHub to deploy stuff. Yeah. So like I said, we offer fully managed infrastructure if you want to train your own model. So you don't want to share the data. You want to keep it separate. You want to run the software yourself, but you still don't want to worry about the servers. You can still run it on a fully managed infrastructure. TensorFlow, like I said, was created by Google. It's fully open source. So here are some examples, like I said, real-world cases where this is in play. Search, you see it every day. If you're using an Android phone, Maps, Gmail, and a bunch of other products are all built on this exact same technology. How many people use Gmail? The Gmail app on the phone. Have you guys seen the smart replies? Yeah. So it just recently came out, and this is probably old, but over 12% of all responses on Gmail are now using smart reply.
Could you come back TensorFlow slide?
Sure. This one?
What you're trying to tell?
Just that it's an open source project. That if you wanted to train your own model and you wanted to use the same software, you could go on GitHub right now and download it. Yeah.
So you can do machine learning. You can do machine learning in this.
Yeah. This is pretty high end. If you need, if you have the skills and you can learn it. Doesn't mean you can't learn it, but there's much easier ways to do it also. So this tool, if you've seen it, the first couple of times, like someone sends an email to you, it might propose a reply like sounds good or sounds great, and one has an exclamation point, and you pick one or the other. Over time, it starts learning what your preferences are and how you like to respond. And it takes the context of the email plus this giant data set, and it's pretty amazing. I don't know, I could have full-on conversations without ever writing a word. Yeah.
I have to say, what was really impressive to me, might seem ridiculous. You know, like if you get like an appointment, like you have like an interview or whatever, and Google automatically pull it out and put it in your calendar. That is so useful.
Yeah.
I thought that was cool.
Yeah.
That was cool. And then also Duplex, where they have the robot talking to people and they can't even tell. That's Turing test levels. Well, I don't know.
Yeah.
Would you call it Turing level test?
Turing test. Yeah.
I mean, they couldn't even tell.
Yeah.
Could they? I mean, that's cool.
I just say that one of the more popular projects that are developed at Space Apps Challenge are ones in which use Open NASA API satellite data to read some sort of weather event and then communicate that to people on the ground using AI and like speech to text, any kind of these APIs where it turns some sort of data point into readable English, and you don't need to actually have a person in the middle, and so you can just send out these messages, broadcast everywhere.
And what I'm hoping, again, this is my first Space Apps, I'm super excited about it, is that what you see different this year is that teams that aren't made up of computer scientists and data scientists can actually, because the inputs you give them allow that. So the tools we're going to go in the next module should allow kind of any team to develop applications where you don't have to worry about nuts and bolts stuff, where you can actually take the input and spit something out. Yeah.
So basically, APIs are going to be the way to go. Sorry, APIs are really going to be the way to go, unless something else is going to supersede.
I think so. Again, I've done 3 startups. I do have a technical background. I studied computer science. I had a CTO, co-founder in every one of my startups, but I got very heavy in the cloud stuff, and I don't think I would ever use the concept of a server. I would just get rid of.
Yeah.
All API, all serverless, all cloud functions.
I just want to reiterate something else. In terms of security, actually, that action might even be better because then you can put another gate in
So
front of.
in that previous slide, like I kind of glossed over it, but security at Google is at every layer. And I shouldn't say other clouds, I'm sure they have it too, but again, for us, it's down to the CPU, like the actual physical chip, up to user permissions and stuff like that, and everything in between, so all the APIs and all that stuff.
That has to be the way to go anymore. Thank you.
Yeah. And that same Smart Compose exists in Gmail, which is a little different. It's not the pre-canned, all those that exist. It will actually start to finish your sentences for you. Hit tab and it'll do it. And same thing, like if you have an appointment, it starts tying in other data sets. And it can, again, it just gets smarter and smarter over time. What?
It's handy when you're on the mobile.
Yeah. The Translate app? Oh, yeah.
Email are based on your previous email or the email of the
Yeah, if you get a question, I'll run over.
Put your hand up.
in this NLP program, is the prediction based on your email, previous email, or on the email of general average people?
Both. So it's based on a lot of things. So it's actually based on the context of the person who sent you the email, plus your overall information, plus the machine itself is smarter on language from the overall data set. It's not taking someone else's email and saying, oh, that person likes this place, so he might like it. It's not,
Okay, it's not.
Yeah, but the machine itself is getting smarter because it's billions and billions of emails per second that are, passing through the system. But also, as you are using it, when you tab, when you don't, when you're selecting, it starts to understand your preferences.
Yes, because maybe it's pre-trained by the other email and after training.
Your previous email, yeah, of course. So again, that same thing, if you're someone that uses exclamation points or smileys or whatever, it's not going to keep proposing that to you.
Okay.
Yeah.
Okay, thank you.
So has anyone used the Translate app? The visual API or the actual text? And this actually combines both, but yeah, it's pretty amazing. You go to another country with a completely different script. This is showing the opposite, English to something else, but you can just hold up your phone and it'll translate a sign in real time, a menu. It's incredible.
So I use a thing called Web Captioner, which uses the Google Translate API to run captions on streams. And in fact, it's something I haven't talked to Joseph about, but we may use it if we've got a separate monitor that will run it to caption the presentations live at the Space Apps.
Yeah. And this is, the reason I put this one in here is it's a combination of multiple of these APIs. And again, I'll show you in the next module. You can tie all these together, give it a video or a photo, and it can print it out to text, translate it, identify signs and logos in the image in each frame, and output it however you want. Joe.
Hello. I lived in China in 2014, and I couldn't live without this.
That was the first time I tried it also was in China.
And it was amazing. Like, it was my best friend.
Yeah.
So I just wanted to add that.
Yeah. And again, these things seem like magic, and we'll talk about, they're not magic. And where they would be magic is, multi-billion and trillion-dollar companies can do all this, but now any of us can. So this is some of those services, like I said, all the way on the other end. Some of this is repetitive, though. You can do it all on your own, manage your machines, run the code. You don't even have to do it on Google Cloud, all the way to these pre-trained, easy-to-use APIs, which I'll show you how to do that, and then somewhere in between. I'm going to focus most of the next talk on this easy, flexible stuff, with the assumption that you only have a limited amount of time at the hackathon. You're going to get this information, how you can get up and running before the hackathon even starts, and then just work on your application or system then. So just again, traditional machine learning historically has required a lot of assembly. You got to get the data, you got to do all this stuff, and then it makes some sort of prediction. Everything that we've done is basically get rid of that for you. Just take what comes in, and it'll spit out something that you can do something really cool with. So, are we machine learning ready for this weekend? The biggest thing to ask yourself is the problem you're trying to solve, does it really need machine learning? You see this across the board with startups for anything. We're an AI company, we're a machine learning company, we're a blockchain company. The first question is, why do you need that tech, or is it just cool to say that tech? Is the problem you're solving, does it really require it? So I can give an example. If it's 78 degrees outside, put the AC on. That doesn't need machine learning, right? That's a simple, yeah. However, if it's a high-risk pregnancy ward, and everything from the week that the woman is in labor to her heart rate to the weather outside to whatever, adjust the temperature of the room, and it can actually reduce early-term pregnancy. I'm making all this up, but that's something where you want the machines to get smarter, and you want it to apply those rules. You want good quality data. High volume, completeness is important. Like I said, there are examples where with something like 11 data points, you can actually, using the friendly AI stuff, you can get some really good stuff out of it. That's because of all the other information Google has. One thing to note, though, is even with technically sound data, if the data set is flawed, the computer is not going to make it any smarter. So an example that I like is if you take all the famous scientists and entrepreneurs in the world and feed it into a computer, the computer is going to tell you that every famous entrepreneur and scientist of the future is going to be some rich white male. And that's obviously not true, but that's the systems we have. And if you look at certain terms that are high flags for toxicity in chat rooms, certain words that shouldn't be negative have a negative connotation because the history of our vocabulary has put a negative bias on it. So just so you know, as smart as the computers are, they're really dumb. They don't have any human sense. And And then skills, knowing where your skills are. If you are a data scientist, if you are a software developer and you can take TensorFlow and run the machines, awesome. If you're not, and your problem doesn't require that kind of lift, and it's just going to slow you down, I wouldn't recommend going that angle. You can get all the power, if not more, without getting down to the nuts and bolts. So again, this is that same spectrum of flexibility. You can use the simple stuff, cloud-based or mobile, and I'll show you how to do it. It can be a simple Node.js or HTTP call using JSON, and you can create some really powerful stuff all the way down to developing your own models and training your machines. And like I said, the first rule of machine learning is if you don't have to build a model, don't. Any questions on machine learning before we move to the next module?
I got a question. So you mentioned that there's pre-trained data sets. Hackathons past, we get people who, not just Space Apps, but a lot of hackathons I've been to, people want to use machine learning, and they start building their data sets, or they start feeding their data sets like halfway through the hackathon. They don't really have a predictive model ready to go by the time the hackathon's done.
Yeah.
What kind of lead-up time do you think people would need in order to train their algorithms?
Yeah, so it also depends on what you're doing, right? So you gave an example of satellite imagery. You might want to, there's one example of, is it snow or clouds, which is actually a really hard problem to solve. There's a lot of data already in the system, so someone wouldn't have to train a model with that data set. Identifying patterns and things in data sets you can feed into this that are really good. I would say the only thing where you'd want lead time, and I don't think anyone here will have lead time though, right? Do they have access to data now, or they get it that day?
So everybody has access to the challenges right now. There's nothing stopping us from nothing stopping you guys from working on anything. We just try to have everybody start at the same time just for fairness, but people start ahead of time.
Yeah, I mean, more lead time the better. Again, depending on where you're starting. If you're using the easy ML stuff, then none. Just, you feed it a picture and it'll give you some information. If it's something completely new, then it takes a lot of compute power depending on the size of the data set. So, and I'm assuming you're not going to get it right the first time, so days at least.
Sorry, my question's for you actually. Wait, where are the random? Where are the challenges? We can actually see the challenges right now.
Sure, yeah, so I'll talk more about this after the talk, but the challenges are posted online. There's about 20 of them. During the October 19th at the Lower East Side Girls Club, we'll go over all the challenges with scientists talking about them and give you the context we're talking about here in machine learning of understanding what these data sets mean. We'll go over all that with the challenges so that you can figure out the best way to apply these tools to solve these problems. This whole talk is being recorded. It's being uploaded to YouTube.
Except when people don't speak on
the mic. October 19th will be recorded too. We do encourage everybody who's going to that con to attend the October 19th event. We will give more information about that later though.
Yeah, just if you look at the categories have been up for a while. You click on the categories now and the challenges are under them. So if you've seen the page with the categories, which are very, very broad, there are like 3 or 4 under each one.
I'm going to suggest we just power through the last one, and then we can use the rest of the time to network and hang out. So like I said, what I wanted to do is end this with something practical that you can start working on now or at the hackathon. So I'm going to try to show you the tools that you can use immediately to get started and build something. We're not going to go too much. It's not interactive, like it's not going to be a how-to, but it should give you an overview of the pieces you'll need. So does anybody here know what Firebase is? Oh, wow. Like better than me, which I don't know it that well. So, who has no idea what Firebase is? So I didn't know either before. It's It's Google's mobile platform. So you can think of it as an SDK, software development kit that you can plug into your system to easily develop apps without worrying about normal features that people expect that you would have had to build yourself a few years ago. So I can give a couple of examples, like running on Android and iOS and having similar experiences, sending a message from iOS to Android to web, or whatever you're doing, uploading a photo, deleting a photo, putting a filter on a photo, all these things that, again, are highly technical, but all this stuff comes out of the box. And then analytics as well. So everything that people are doing, you don't have to actually build your own analytics. You'll get all that information. Login, authentication. Again, each of these are huge technical problems, but this all comes built in. I'm trying to think what else. We'll talk about a couple of other cases where that matters. But I'll give you my favorite example, which it hurt me a lot in my startups. We live in New York City. You're uploading a photo, you go into the subway, and the internet drops, and then that delivery fails. Back a few years ago, if you were ever using apps, it would just be gone. You wouldn't even know. Handling that type of asynchronous connectivity comes out of the box with stuff like that, where these are problems that you might not even think exist for some of your users, but again, Firebase is taking care of all that. It still drops, but at least it tells you not delivered. But some apps are pretty good, though. Some will pick up. I think Gmail has gotten really good at that. It'll keep circling, and then once you get back connectivity, it'll send it. So we're going to talk a lot about this concept of serverless. So what I'm doing in this presentation is combining Firebase, which will allow you to quickly deploy apps, meaning like you could put one up right now and have something ready to go in no time. Firebase plus this concept of a serverless solution. So we talked about cloud computing and machine learning in theory, this concept of virtual machines and a computer getting smart on data set. Like I said, you don't need to worry about any of that. It's all taken care of. Serverless takes it to a next level. You don't need to actually worry about a machine. So there's no concept of I'm going to provision a Linux machine with this much RAM and all that stuff. You don't have to manage servers. And you only pay for what you use, which means a lot when it comes to serverless. Serverless computing is basically like on-demand functions. You need the computer to do something, but only when someone needs it done. Sorry, I'm
trying to is this something you have to download if it's serverless? Is it something you can download?
So you don't even have to. So there is a server, there is stuff that happens, but these are APIs. So you'd create your app on Firebase, and I'll show you what these triggers and functions mean. But for example, your users have to upload an app, right? Within Firebase, you can tell it, okay, upload the app. The serverless function call will be, there's upload the photo, there's a photo coming, stored in a database.
So you're really using the app in order to get, is the gateway to using this?
So it's the overall system. It's the code that's in the app. It's the code that's in the back end, the code that's running on Google Cloud.
Okay, so that's the back end enabling all the connection.
Yeah.
Thank you.
Yeah. So you can think of this also back end as a service and just all these things that, yeah. And the pay for what you use, again, is you don't have a server running all the time. It literally only runs when that function is called, yeah. I think this is the future by far. So we talked about these cloud functions, again, no server management, automatic scaling, both up and down. Let's say you launch an app that weekend and it's a hit. You don't have to worry about it going down. And then if it's not a hit, you're not paying for servers for no reason. So I think the most important piece is this concept of a trigger. I'm not going to go into too much detail about it, but again, that trigger can come from anywhere. It can come from a user action. It can come from some sort of listener you create when something changes in the database, or there's some other external event and you want to notify people about it. All these are events that you can create that can call a function or a combination of functions. So for example, I'm making up an app, theoretical app. Someone takes a picture of a sign and they want to in another country, and they want to translate it for something, not for their immediate use. The app can take that picture, use the Vision API to identify the sign, feed it to the Translate API to actually translate it, and use a speech to text to speak it to someone. Let's say that was the purpose of the app. The purpose of the app is for the visually impaired. So one traveler can do it. All that stuff can be done now through a serverless solution, and we'll talk about it. And again, someone had asked, how do you deploy this? There's 3 simple ways. There's the Cloud Console, where when you sign up for the credits, you'll see. It's a beautiful interface. There is the command line, so you can literally go in and, just like you would with any sort of operating system, and then if you use GitHub or any source code repository through your commands through that, you can deploy code directly to it.
The Cloud Console, is it only Node.js?
Good question. I don't know. I'll find out. I'll find out before we leave, but I don't think so. So again, this is just an example. Again, I don't want to get too technical, but those of you who are technical in Node, you can write a function and it will spit out what you expect it to spit out. But again, just even not that long ago, you would have had to set up a server to listen for that.
I just have a quick question, because the few lines of code, you've got HTTPS endpoint, and then you've got dynamically generated SSL. Is that /TSL cert? Is that not a duplication, or I thought that would be one of the same? No.
Don't know. We can find out. But remember that question. Talk to me about it afterwards. And also we have an emulator, so even though it is serverless, you can run this on your local machine to test it out and see how it works. So again, we talked a little bit about this concept of the functions and the triggers. It's everything from the authentication to the database, and like I said, I'll walk through a couple of architecture examples of that. And the cloud functions plugged into Firebase allow you to deploy this app on multiple platforms and create whatever, again, solution you're creating without having to develop all these other pieces of the code. They come in built in with this. Also storage. I don't want to go into too much detail about this. But okay, so we talked about that example. You've built an app on Firebase that deploys onto an Android device or an iOS device, and your user uploads an image. It'll immediately go into storage, and you can run those functions, like we talked about that visually impaired speech-to-text translation for a sign. And what will happen is you'll give it the image. It will return you a URL, which is your download URL for whatever you might want to use it for display or for bookmarking or whatever, and it'll store it in real time into the database. Again, all stuff you don't really even need to worry about. That database, like we talked about, is synced using multiple technologies, so across devices, across platforms, with or without connectivity. And then this is an example in the reverse that we talked about. So now in this scenario that we made up, you are the person, you're the visually impaired person that is awaiting the sign to be notified. Someone has made some changes or uploaded a sign, and it has been translated, and the trigger might be either the user uploaded it or some new translation came out. And in the functions, you could tell it to notify whoever is listening for that specific topic.
The new voice access that you've now brought out, Google can also do all of this? Yeah. Okay, great, fantastic.
Yeah, so also anything that you see in the assistant, I didn't talk about the assistant at all, but if anyone uses Google Assistant, that's all, yeah. Yeah, yeah. It's a very good point. There's another software that we're not going to talk about today, but you could use it. It's called Dialogflow, so which basically, without writing code, you can explain to an assistant how to communicate with the user. And again, that messaging that we talked about, to different users, different user groups, different triggers that cause that messaging. That's all baked in. You don't really have to learn anything about it, and it's a cross-platform. These are things that can cause headaches for developers. And like I said, for your app on the weekend of the hackathon, you can actually have all these bells and whistles that are going to make it look that much more powerful, which maybe a year ago or a few years ago you would have had to know how to code that stuff.
And remember, you don't actually have to make it work. You just have to make it seem like it's working for the demos. So keep that in mind.
Oh.
Make it work, but just...
So the whole point is with these tools, it will be a lot more workable than you think it's going to be.
Yeah, I wanted to point out at some point that this solves one of the biggest problems with hackathons, which is you start hacking on Saturday morning, and then you fiddle with the infrastructure, getting your servers set up and configured, and learning what different tools are. And then by the time Sunday rolls around, now you start putting your IP into the actual project. You want to get this out of the way as soon as possible. Hit the ground running, start Saturday morning just working on your app, and then deploy it, not have to worry about any of this stuff, because this stuff is really what comes to bite you when demo time comes around. Something, wiring doesn't work, this is what's going to fix that.
So to that point, that wiring, this is just showing that you'll go into Firebase, you'll create all the pieces you want, and you deploy it with one command, and you'll be up and running. That wiring stuff you don't have to worry about, and this is something you can get started messing around with before. Just to learn how Firebase, but even if you start that day, it's a pretty good interface. The other thing I would recommend with any of this stuff is go on YouTube. There's a bunch of documentation you can learn from it, but the community has created all this stuff to show you how to knock this stuff out. If you can do it before the hackathon, awesome. If you do it at the hackathon, there are people that have created incredible things, like young high school students that have created cancer detection platforms using TensorFlow and Firebase, which is incredible, that no one would have ever thought of. And then also, someone was asking about analytics before. So Google Analytics is tied into Firebase. So everything you're doing, a lot of times startups will create an app, launch it, people will start using it, and analytics will be an afterthought. They'll be like, oh, we don't even know what's working, what's not. All that stuff is baked in here. So you'll get detailed reports on which interfaces, which buttons are working best for your app. And then Firebase predictions. This is, again, built into the system. If you're doing anything with with media, data, text, voice, using the functions or not, the fact that it's built into this system, you get the access to Firebase predictions, which is essentially machine learning that you can then deploy to different user base and user groups. For example, in that hypothetical situation, the people who aren't visually impaired, who are taking the photos, with the ones who are using the speech to text, there can be different predictions for each group based on who travels to which location more, who needs certain signs more than that. I mean, even if you don't use it, but you start building your app and you're putting the data in, you have access to go back and do all this stuff. It's not like an afterthought.
Basically K-means, right?
Say it again?
K-means, sorry. It's basically clustering algorithm, K-means, right? Are you familiar?
No, I'm not.
Oh, it's cool. Oh, no, sorry.
No. Well, you can explain it.
It's a clustering K-means is clustering. It's unsupervised learning where basically, you give the computer a bunch of data, you say, well, find groups, you specify
pattern, yeah.
how many groups, and then it looks for the groups and tells you what it sees, tells you what it sees, basically.
Yeah.
So, cool. Sorry.
And that's it for the overall presentation. So again, the goal was to, thank you. I wasn't looking for that, but the goal was to kind of give you a high-level vocabulary and then actual tools that you can use for the hackathon. So if you have any questions, we can definitely field them now about Firebase or Google Cloud or ML.
Anybody have any questions?
Is there documentation? Is there a simple tutorial or just documentation on, because the image really caught my attention, I can build a simple web application, feed an image with an upload function.
Yeah.
And then just use, I guess, Google's machine learning to just like generate some tags or like identify key things in the photo, colors, red, blue,
Yeah.
whatever. The shape is a circle, something like that. And then I can do the dirty work of like pulling out the important stuff.
So, sorry, what was the question? Is there documentation?
Is there like, yeah, documentation,
Yeah,
just like
so,
a simple
yeah, a good place to start is cloud.google.com. That'll free will get you the $300 in credits. But it's a good place to start to see all the available products that you have. And then for each, there's detailed documentation. But like I said, I would just check on YouTube. And I think you'll find some like pretty like knowledgeable people, both from Google and from the community, that might have the exact answer that you're looking for.
For sure. Thank you.
I was under the impression that you could use Firebase just for temporary data storage, but I didn't know that you could deploy your apps.
Yeah,
in Firebase.
yeah. You can do both. You can use it for temporary storage, even long-term storage. You can use it as a full mobile platform.
I have a couple of logistical questions. Can you integrate the messaging with another program like HubSpot or Salesforce?
Interesting. I don't know the answer off the top of my head. I'll check, but I guess would be yes, but I don't know.
Okay.
And even if it's not out of the box, someone's must have had that problem before.
And my other question is it best to sign up for the credits with an existing AdWords or Google Analytics account, or is it something that's shareable with your team members?
It's different. So the Google Cloud Console and Cloud, it'll probably use the same Google login, but it'll be a different account. So your AdWords account and your Analytics account are not your cloud account.
But you can connect them?
Sure, you can connect them from a data standpoint.
Got it.
So all your analytics information, that can be, we didn't talk about some of the other services we have, but you can pump in data from, so this might answer the previous question also, from obviously any of Google's tools like Analytics and AdWords, and a bunch of third-party tools. And it's this product called PubSub, which is a way to stream data or get data in batches and have different parts of your system listen in and notify you when something changes or based on whatever rules your application might have.
And can I share at least the platform views or the dashboard views with team members?
Yeah.
Or do they each have to have their own account?
They probably need their own login
Right.
account, but it would be like, so for example, when you sign up for the credits, if you already have a cloud account, it's gonna ask you for your billing account. If you don't, you'll create one and you'll get a billing account, which is your company or your team's account.
Okay, thank you.
Sorry. Given that most of us have all Gmail and that Google Drive is really the cloud, is that the account they're going to ask for?
Sorry, what's the question again?
Given I said that Google Drive is a cloud account, basically.
It's
is this
not,
going to
it's
be
not the
separate?
same.
It's not the
So
same.
this is
Okay.
for like cloud computing. It wouldn't count towards your personal like
It won't?
drive
Okay.
or your enterprise fees for Gmail or Drive or stuff like that.
So this is something totally separate if you sign up for these credits?
Yeah, you wouldn't be able to apply these
Oh,
to.
you can't associate it with the Gmail account?
No, so you can think of it as a consumer cloud and then the developer cloud. So if your app is using stuff and storing on this, yes, those credits count towards that. But if you're putting files or
It's the same like Google account, it's just like a different
billing, yeah.
Okay. Got it, thanks.
You could think of it like these are a bunch of different products that have their own account. You could use the same Google login to access those accounts, but they are separate accounts, and you can share data between them.
Now, if you're eligible for the startup account, there are some credits and some perks of that where you get some Gmail accounts, you get some discounts on stuff, but that's really for startups.
Can we export the machine learning model for offline use?
I believe so. I think it depends, though, on which level you go at. I don't know, but my guess is on the easy-to-use stuff, probably not, because you're just using the function, and it's using an already a trained model. Definitely if you're using the AutoML, or if you're just taking TensorFlow off GitHub, yeah, you can absolutely do it. Yeah.
Okay, I guess maybe this is a question for both of you. For those of us who have not participated in a hackathon before, can you tell us what's the best way to get ready so that we can be useful?
So those who are not or are?
The simple answer to that is we have another boot camp on Monday the 15th, so it's this upcoming Monday, at SAP Next Gen. I'll share the Eventbrite with everybody. It's an intro to the Space Apps Challenge and open NASA APIs. And so we're going to have a couple teams from last year come back and represent their projects. You can ask them questions about their experience. We're going to have some data knots, which are NASA data scientists, come and present open NASA APIs so you can understand the different data sets you'll be working with. And the whole point of it is to just give you a quick understanding of here's what a hackathon is, here's the experience, here's what to expect. And you can ask questions of past hackers, mentors, organizers, anybody. I would say just in a nutshell, you're going to come to the orientation event on Friday the 19th. You're going to sit in a presentation like this and we're going to explain the challenges to you. You're then going to break up and ask questions about the challenges and form teams. We have a Slack right now, a Slack account for everyone who's registered for the hackathon. I encourage everybody to join. We'll create a Google Cloud channel, so if you have any questions or need mentorship or something, you can go in that channel and ask questions there. And it's a way for you to really get organized before the Saturday event. And if anybody has any questions at any point in the hackathon, feel free to email me, ping us on Slack, anything like that. We're here to help you get ready and get comfortable working on your team.
You had a question?
Do you know what are the criteria for being eligible for startup?
Yeah, I can explain that now. So the startup program, which I run in New York, is designed for early stage startups. Eligibility means a few things. It should be a tech-enabled, commercial, scalable startup. So, no, we're global. There's certain territories that we're not in, but you'll see when you sign up, and I doubt you're, but, and then and it has to be less than 5 years old. Like I said, less than 5 million raised or less than $500,000 in revenue. I think what else? That's really it in terms of criteria. And you couldn't have received credits in the past. If you've received these credits in the past, you can't get them a second time. With that said, there are other tiers. So if you are a startup and you're part of a co-working space, an accelerator, or a VC fund, we have different tiers of credits that they can offer to their portfolio. And like I said, from an eligibility standpoint, if what you create in the hackathon is something that you want to actually go commercialize and create, turn into a business, you can definitely apply for this. If you don't have a startup, though, I wouldn't apply because you're probably going to get rejected. But any developer can sign up and get that right now, and you can always upgrade.
And we do have, not only in New York, but other locations have had teams go on and present their projects at other hackathons, continue their project, and even develop them into startups. This is a space where it is, I wouldn't say easy, there is no entrepreneurship that's easy, but there is a wide opening for space startups and startups that use space technology like this. So we're here to help you. We have partners, accelerators, VCs in New York that would help you with your team to move forward after the hackathon should you choose so. And this is one tool that would help you do that.
Any other questions about this stuff? And I'll hang around for a little bit. I can share my contact with everyone, so if you have any questions. Great, thank you.
All right, thanks, Tej. So I think that wraps it up for tonight. We'll be hanging around for a little while longer for networking. If there's any pizza left, feel free to that. Like I said, myself, Tej, folks from Silicon Harlem will be sticking around. If you want to chat, go to spaceapps.nyc, sign up to the mailing list. I will email everybody who attended here. If you have not registered for this event, come see me so I can get your email. I'll tell you about all the other boot camps and the hackathon and everything going on this week.
Yeah, hi, I'm Dave Pentecost. I'm with believe it or not, with the Lower East Side Girls Club. I'm one of your hosts for the hackathon, so welcome in advance. We'll see you that weekend, and I hope I see some of you for the boot camp for open space. You may not know there is a planetarium on Avenue D. That's where I hide out. And we're going to be demonstrating OpenSpace, which is new astronomy software from the Museum of Natural History's team. We're going to be demonstrating that on the Wednesday, and then their team, a couple of their team will be there all weekend for the hackathon. So if anybody wants to do anything or learn about open space, we'll be there. Yeah. You can download Open Space Project. Open Space right now, you go to openspaceproject.com, free download from Mac or Windows, and yeah, you can take a look at it, fly through space, but it's got some interesting access to NASA databases of surface of Moon, Mars, everything else.
What date is that?
Yeah, that's the date.
What's that? Wednesday before the hackathon, the 17th it's on the website under all these boot camps. It's a boot camp. And then all weekend.
Yep. And I'll email everybody all the links to all the Eventbrites for all the events going on. That's one of them. Super excited for it. If anyone's been to the Hayden Planetarium and saw any flybys of Mars and any of the after hours lectures, that's the software that you would be using to do really cool stuff. Cool, so with that, I want to thank you all for coming, and I'll see you at the hackathon.